Hi guys, Frankenstein here. Today we're gonna be solving for the following. The total resistance, total current, the current through R1, the voltage across R3, and the power dissipation for the entire circuit. So basically we need to find the power that is dissipated by entire circuit. So first of all, what you're gonna do is actually calculate. Let's just zoom in there. Let's calculate the first one, which is R tot. Okay, let's calculate R total. Okay, how are we going to do that? So first of all, we have to find R total, right? So R total, how are we going to do that? We check. So R1, this one, and R2 are actually in parallel, agreed? So we can find that first. So we know that we're going to say the first one, the first R parallel 1, we'll name it R parallel 1, is equivalent to R1 multiplied by R2 divided by R1 plus R2. That is equivalent to it. It's going to be 180 multiplied by 150 divided by what? 180 plus 150. And we can check that in our calculator. 180 multiplied by 1. Our answer is actually 900 over 11. Let's keep it that way, right? So that's the first junction. So already we've made this one a resistor in series. So we don't have a resistor in parallel, we have a series resistor, which that is our parallel 1, right? We are fine. And then let's try and make also this thing a series resistor so that we can plus them together. So another section, we can say another R parallel 2, right? But inside R parallel 2, we can see that this one has only one resistor, this R3, but R4 and R5 are actually in what? In series, right? So we can just, let's erase that and actually solve for that first. So we are going to say R series 1 is equivalent to R4 plus R5. Fine. And then let's go substitute. So it's going to be 33 ohms plus 82 ohms, but we don't have to put it there. We know it's ohms. And then let's punch that in a calculator. Getting our answer to be 115, right? So we know that now already that we have okay, we know now that we have made this portion here one resistor, right? Which that is actually RS1, right? But we can actually realize that this portion and this portion are actually in what? In parallel. So we can put them together in parallel. So we're going to say therefore R parallel 2 is equivalent to it. Remember, this section is RS1 multiplied by R3 divided by RS1 plus R3, right? Because that's the parallel formula. And then RS1 is 115 multiplied by what is R3? R3 is 120 divided by 115 plus 120. Then we get our answer to be our answer is actually 2760 divided by 47. 47, right? So what we're going to notice is that we can actually, we have this one. Sorry there, guys. Oh my word. Okay, let's go back. Sorry guys there. So we have R parallel R parallel 2 and R parallel 1, which it's this section and this section, and we can actually realize that this portion here and this portion here are in what? Are in series with each other. Agreed? So we can add them together to find total resistance. So we can therefore say that R total is equivalent to R parallel 1 plus R parallel 2. And that will be, R parallel 1 is 900 over 11 plus 2760 over 47. And I'm keeping them as fractions because I don't want to lose those decimal points. It's very important. Some lecturers are very, very demanding. They want to see the actual answer. They want to see an approximated answer. They want to actually see the actual answer. So my total resistance is supposed to be 140.4554, sorry. And that is actually ohms. So that's the total resistance, right? I'm going to keep that resistance total just for later on. So, just keep it. Just keep it down there. And then I'm just going to wrap everything so that we have more space to work. Just make it snappy a bit. And also this problem it's quite a nice basic question in terms of when you're doing electrical engineering. It's basically a basic question, guys. So there we have it. First answer. Just try and get rid of some stuff here. Got carried away, made a mess, but I'll try and remove it. Okay, yeah, there we go. I think this is more visible. It's more than visible. Okay, so we managed to kill this one. We managed to kill the first question. Now let's kill the second question. They want the total current. So that one, I think it's basic. You guys are probably happy. We know that what I want you guys to understand is that once you're looking for total current, just go to ohm. Don't think about it. And you know that ohm is var. So it's going to be V is equal to I R, right? I'm looking for current. Therefore, I have I is equal to V over R, but V has to be V total, but you can actually expand that to E and also R total, and then change that section so that you know that you're looking for total current. Therefore, you must have your E being the total, voltage and also R being the total resistance. Therefore, you can sub in what is E. E is 25 total voltage inside the circuit, and then RT is the total resistance in the circuit, which is 140.54 ohms. And let's try and get that. How much is it? Our current is 177 milliamps. Well, we can actually go further and say it's actually 177.88 milliamps, but any we given marks for. So also I total, we're gonna take that answer as well, because remember, when you're doing these kind of problems, the answers kind of need each other. At the end, the answers need each other, so you need to make sure that you just, after finding the answer, just keep it close, because with the next question you might actually need it, right? You might actually need it. And also for total current, you don't have to worry a lot. Once you've found the total resistance, just go to the voltage of the battery and you'll be fine. Everything will just work itself out. So that's the second answer, and we've killed that section there. And then let's go check for the current which is flowing through what? The current flowing through R1, right? Let's go and check that circuit. So they're looking for the current which is flowing through R1. So R1, where is R1? R1 is here. So they're looking for the current flowing here, right? So how can you go about that one? How? Okay, what we have to realize is that we have the total current. We can agree that the current flowing here is actually I total, right? Right? And then the current will actually split here. Will split, some current will flow this section and some current will flow this section, right? But remember that after here, the current will actually join together. Current will actually join together here and be total. So here it will be I total. So these currents will come about and adding each other. So we have to use the current divider rule there. Is it fine? We're going to use the current divider rule between R1 and R2. Is it fine? Okay, let's go through it. So let's try and get that one. So the current through R1, remember, we have to have what? The current. We have the total current, yes we do. So we're going to say IT multiplied by the what? By the opposite resistor, remember, which means you're going to use what? R2, because you're looking for R1, divided by R1 plus R2. Very important. Current is inverse to voltage, so when you're looking for the current, you must use the opposite resistor so that you can find the actual current you're looking for. So meaning that here, total current is 177 times 10 to the power 3, or negative 3, sorry, multiplied by R2 is 150 divided by R1 is 180 plus 150, and that should be working out to 80.86 milliamps. Very important, milliamps. So that's IR1. So that's how you got it. So because if I'm looking for the current in this portion here on this section here, I'm gonna have the resistor of the opposite one. Since I'm looking for R1, R2, here in this portion I was gonna use R1, but here because I was looking for R1, I'm gonna use the resistor here for R2. That's what I did there. So that's the only thing you have to understand, that during the current you must use the opposite resistor, not the actual resistor but the opposite resistor. Now let's continue. Okay. Okay, just drag that to a respected area. Hopefully I'll still have some space there. Keep it a bit close. Now it's calm. So that's the other one. There we go. So we've got that one, we've got this one, we've got that one. So we managed to kill IR1 as well. Now let's go to VR3. So in VR3, what can we do? We're looking for the voltage of VR3. Okay, let me just erase this just to keep our circuit clean. Again. Okay, it's fine now. So VR3, so we're looking for the voltage across here. Oh my word. Voltage across this resistor here. So what can we do, right? So we have a couple of various ways, but a more theoretical approach is to actually understand that you can actually find the current flowing through there. Right? You can find the current through that resistor. And then once you find that current through that resistor, you are gonna be able to have, you're gonna have the resistance and the current, which you can find the voltage. So main thing first, you must find the current flowing through there. So once you find the current, everything is fine. Now let's go and attempt and find the current. Let's find the current. So we're gonna say what? We're gonna say current through that one, which is IR3 is equal to I total, very important, multiplied by R. Remember, I'm looking for the thing here, for the current here. So meaning I must use the resistance for here. So in brackets, R4 plus R5. And then we have divided by R3 plus R4 plus R5. Now you might be asking yourself, why am I multiplying by R4 plus R5? Because I realize that these ones are in series and I want to have one resistor, so I must pair them inside a bracket so that they are basically one resistor, so they're going to have one value at the end. And then yeah, that's it. So let me just continue. So our answer is going to be there. So it's going to be 177 times 10 to the power negative 3 brackets multiplied by, again, R4 is 33 plus 82 close brackets, then divided by R3 is what? Is 120 plus R4 is 33 plus 82. That is equivalent to, smash that in our calculator. -3 . My current there is actually 86.62 milliamps. That's 62, by the way, milliamps. So I got 86.62 milliamps. So meaning that that's my current there in the R3 resistor, right? So I'll just take that off. And if you notice that most of the answers we get, we actually reuse them. So it's very much advisable that's IR3. It's very much advisable that every answer you get, you must keep it aside so that you can use it later on. Very important, especially in circuit analysis. Then, so we have the current flowing here, and we have the resistance. We can find the voltage. Therefore, voltage V is equal to I R, right? I'm looking for the voltage across what? R3. Current has to be what? Has to be I R3 multiplied by R what? R3, so that everything matches. So my answer is going to be IR3 is 86.62 times 10 to the power negative 3, brackets open. R3 is 120. And let's check what is our answer to be. So our voltage there is 10.39 volts. That's our voltage there. So that's VR3, right? And then let's erase the other parts. We don't need them. Then let's just drag that. Okay. And line it, just like keeping things neat. So we've killed VR3, which they wanted. Now let's check the power dissipated by the whole circuit. So this is it reads like a hard question, but it's not once you understand the formulas and everything. So the basic power formula, which you must know by head, you must just spit it out, is very important. It's P power is equal to IV, right? Meaning current and the voltage. And then what is that current supposed to be? It's supposed to be I total, because they said by the whole circuit, then multiplied by V total, which you can actually write that as E. E means the total voltage in the circuit. So I total, we actually calculate I total to be 177 times 10 to the power negative 3. And then E is actually 10.39 volts. Then let's see what is the total power dissipation of this entire circuit. Okay. Oh, sorry there. The voltage is actually gotten wrong, because the voltage, remember, E is 25. Sorry guys. The 25 multiplied by 177 times 10. So we have a power of 4.425 watts. That should be our answer, guys. Very important, but let's just keep it neat, nice and neat. So power remove those. Just put it perfectly there in the bottom as our last answer, and let's keep it on us underlining, so that you can also, when you practice those questions that are on top, you all know that this one is for question 1, question 2, question 3. They just go in their order. But yeah, guys, this is how you'd solve these questions. And sorry, the video is quite long, but I wanted you guys to get a theoretical concept on how to think about it. But once you understand ohm and everything will just work out perfectly fine. But yeah, man, meet you in the next one. Cheers.